Very good morning and Salam Sejahtera. My name is Peter Lim. I'll be your facilitator this morning for next 45 minutes. Welcome to the series of Empowering Your College Mathematics in the series number 3. In fact, in the past 4 weeks, we have done 4 series. 3 series are in the public and 1 series actually internal. We have covered algebraic calculation. We have covered logic, graph and network, and today we are covering applied statistics, and either in a field of science, engineering, business, doesn't matter. And we had just another internal session that was wonderful as well. We had over 30 students from one class on discrete math. We actually showcase how to do Wolfram Mathematica for algorithm design. Yeah, of course, by all means, today, either in a field engineering, science, or business, in the event of Industrial 4.0, we can't seem to get away with dealing with data analytics, and also coding. So I have been a few industrial managements as well with academic consulting for past 20 over years. And more, when I spoke with some of the either people or professors, lecturers, or students who graduated into commercial world, private sectors, or public sector, they say that, oh, I wish so much I learned a little bit more about coding. Yes, today, if you want to able to further have one head start compared to your peers, and in the Industrial 4.0, people are crazy about how you handle data, how you make sense out of data, how you automate your knowledge so it can be turned to algorithm and can share with your peers, communities, and the world. So today, I'll share with you not from a perspective like textbook approach, even though we talk about college mathematics, how to empower college mathematics, but we are not showing in a step-by-step how from A to B to Z, but rather when I showcase about using Wolfram Language as applied statistics, I'll share from many different perspectives. So it will not necessarily flow in a manner that we actually, most of the time that people like to do, like for instance, I start with descriptive statistics, how to handle with data, repository, curated sources. You might not know what's curated sources, it's okay. Along the way, when I show some example, you from, oh, this is what you're talking about curated data and in the market. So many people are talking about it, how to make use of repository, or how do we do visualizations, how do we do probabilistic and model, how to do a data fitting, so on and so forth, a simulation. So I will not necessarily go on this flow, but I hope to blend in a very simple background and foundation in statistics to all the way how I'll showcase how we can deploy a little bit some advanced versions of applied statistics, so get the balance between. So not say, hey, yeah, talking about some like I've been doing in calculators and certain website, I've been doing in pen and pencil. You're talking about primary school thing. We want to make sure it's simple enough for you to understand. At the same time, and I'd like you to inspire how you actually can make use today robust tool like Wolfram Mathematica to make your things easier to understand, easier to learn, fun to teach, also good to safe keep your knowledge even for your internal reference in futures or maybe publications someday. Now, of course, we start with descriptive statistic, but I like to show with you one good thing is that this day a lot of packages come with functions, libraries. Wolfram Mathematica, if you have installed, I know many of you have access to Wolfram Mathematica. If you say, hey, I do not have no issues, talk to Desmond, our facilitator today will be in charge of chat room. So along the presentation and sharing with you, if you have any questions, do type in chat room. Desmond will be responding to you. And if you do have questions, hey, how do I get hold one copy of this? And how do I find one copy? Maybe I don't want even to pay for that. So how do I do that? Yeah, Desmond will share with you some of the means and ways. Now, inside Wolfram Mathematica, if you want to learn or teach statistics, you have to deal with, of course, example data. There's huge number of example data here. I'm not going through one by one. There's a lot of classical data available, but again, very helpful thing is, oh, there's a lot of data available, but what if I'm dealing with external data? So today, if you're dealing with data handling or statistics, you want to know what kind of data the system can integrate with. Today, no software can exist on its own, very seldom, unless you're self-developed own proprietary software. But this day, we are talking about how you publish the ecosystem efficiently with other robust solutions in the world. For instance, you're using R, you're using Python, SPSS, you're using SAS, it's good enough, good. You can carry on, yeah? But you say, hey, I want to further bring the next level. Yeah, Wolfram Mathematica and technology have a lot of things to offer that you can easily integrate. So we have a huge number of format you can deal with. If I say, hey, how many format you can deal with? 226 format. Yeah, of course, most of the time we're doing text file, CSV file, Excel file is very good enough. But I say, hey, I'm not dealing with text file import. I'm dealing with Oracle, SQL. Yes, how could we do? Yes, but it's not in this class. But also one line of code actually can do all the same part. But now, let's say I want to get example data in terms of statistic, employee attitudes. I say, hey, what's this employee attitudes all about? Inside there, there are so many actually information about this thing. But I say, hey, if I want to find out more, of course, when it's a library, there's a way to coding for you to find out what inside there. For instance, I find a coding column heading on this example data. Oh, inside rating, complaints, privilege, learning, how much people get paid, salary, whether this guy is being critical and all that, some advancement he or she already had. So example data in Wolfram Mathematica can be a lot of things, from machine learning, from engineering, from physics, from chemistry. Statistics is just a very small part of it. So I'm using this old faithful, yeah, fountain as an example in California, very famous in Yellowstone, this national park, and so happen it had actually one example inside there, and this simple two array dimensions data, they have actually duration waiting time. What's the duration each time when the fountain bursted, and how long people had to wait until the next burst. So in this case here, I say, okay, I'd like you to give me the old faithful statistic. You can give me a few hundred points for that. With each of the array inside, actually is two dimensionals, yeah, is XYs, which is durations and waiting time. So with this information here, already I can do a lot of statistic calculation to illustrate how does this thing do. So for instance here, I say, hey, if I have this thing, something called my data, I will assign all the output here, this statistic to my data. And I actually, like if I want to learn a bit coding, this is common sense. I think any coding like Python, anything at all, for instance here, I say, hey, I want to get all data, but I only want the first column. First column is what is duration. So you're getting all data from from duration, which is first column. You're doing X, Y, row and column. So, but in this case, I say, hey, I just want to get a mean of this thing. Can you give me a mean? Oh, the average value is 3.48. Same thing, I say, can I give me a variance? Yeah, the way is Wolfram Mathematica works is like, if you're dealing with functions or at least Excel spreadsheet, this is not something that strange and unusual. Like I put variance as function in this data, give me a variance like that. But the good thing is, and like I say, coding this day become very important. Either you choose Python, and you of course Python is free one. The whole community is growing very fast, but Python is good for popular programming. But come to deployment, it really can compete with some commercial package. And the good thing is commercial package this day is so much affordable. And when you want to come deploy visualization, I would say that a lot of like 4 million users of Wolfram Mathematica in the world, they still say, hey, Wolfram Mathematica is much easier to get started with. It's really easier to get started with. So, and also easier to get understand. So of course, there are a little bit here, programming here. I will not explain details. There's a lot of video out there to show you, hey, how to do the big programming here and there. But I'll try to explain a little bit what this thing do. So what this thing do is, it say, hey, this first column, which is duration of my data, or the row, first column, which actually represent duration, I want to make it to be a function. And this function, I want it to be mean, variance, skewness, and all the important moments of descriptive statistics. And I want to get first 10% quartiles and last 90% quartiles. And this whole thing give me a series output programmatically. Yeah, so very simple. See, I want to list this thing in table like that. So if I can list this thing in table like this, so meanings actually, if we want to visualize it, okay, the same way I can do, for instance, in this case, I say, I like to give visualizations. In this case, the function right now similar on top, but I want to show you histogram, whisker chart, as well as distribution chart. I want to show you in grid form. So immediately give me a breakdown of the tables, and showing me on top duration, bottom down is waiting time or the fountain bursting, in between the bursting time of fountain, and it give me the whisker box and the distribution chart, and very quickly. So each of them actually a mouse over very nicely. So in terms of just one line of code, in fact, you can do much more than Excel spreadsheet. Excel spreadsheet, of course, is static and something very predictable, easy to deal with. But a lot of time, if you want to change the data, I want to change even the header, things like that, if you can manually adding in here and there, but even come doing presentation, actually it's quite static. I'm telling you why. You need something dynamic, not just for learning and teaching, but in fact, for publication is very useful. Now, in terms of this data, the bursting duration of Old Faithful fountain, I say, hey, I want to bring the beans. You see, in Excel spreadsheet, actually very difficult to do that. I've been dealing data a lot. Yeah, there could be certain technique to do this, but let's say I want to create a bean, which actually I want to put it between 0 and 2, 2 and 3, 3 and 4, and 4, 10. Bring to 4 beans. So based on this, I call bean counts. Immediately I set it to be a interval between 4 beans. They give me 4 beans right away. So now, if I say, hey, if I have these 4 beans, I want to visualize quickly. I say, so there are many things you see when I type here, the system automatically come up for me. And in fact, there's a reason. If I slow down a little bit, I click what this thing is. You give me actually step by step how to fill out all the syntax. So even though I do not remember the syntax, actually I do not remember most of the syntax. I only remember 5%, which I commonly use. There is a time usually I start and go. Now, if I can create a bar chart like this, and create a bean very easily, next thing I want to visualize it, I say, hey, now if I want to create another function called my functions, and I also put in some commastic thing. This commastic means actually make it beautiful, something what you do like Excel spreadsheet. Yeah, I say chart style, I want to be dark rainbow. There are many different chart type you can select from the chart style. Also label, I say I want to have labeling automatically. And also this my function of this bar chart, I don't want just bar chart, I want a pie chart also. Yeah, so this is something called image size, make it large. I think. Okay, so you can make image how big the size you want. If I do not say what size I want, the system come out default size like this. Yeah, of course I can still make it bigger, smaller, like this. I can hold it out. Everything actually interactive and actually a lot of mouse over. So in this case, immediately I say based on the duration of the bursting time, I say break into 4 bins, immediately I know it's a majority of the bursting time duration lasts for 4 minutes. This is like more than 50% of the time there. So if I further go down, I say, hey, I want to do slightly more visualization. Now, I'm talking more on visualization right now. Yeah. So later on, I go into more things about how they do advanced linear fitting, even non-linear fitting, which is very exciting. Now, on calculator plot, you see, this thing definitely you can't do anything with SPSS, you can do it as SAS. Of course, SAS, SPSS, they're one wonderful tool for business econ analysis. Yeah, you need to use it, yeah, for some of the project. But today, you want to deploy something into some, let's say, IoT or Industrial 4.0 thing, you really need tools like at least Python or Wolfram Mathematica, which are my best choice. Yeah. In this, for example, Pareto chart I create here, you see the whole thing here is not even numeric. At times verbal, even verbal you can process. Meaning this package, like there's a package out there, not many packages out there. A lot of packages actually doing numeric. But Wolfram Mathematica can deal with, you see, this one I put like kucing, ikan, cheese. Yeah. So actually it can also do Pareto chart form, means actually handle symbolically. It's not numerically. That means that today you can handle things symbolically, especially in machine learning age now, artificial intelligence. You're not doing numeric things anymore. You need image, you need the sounds, you need the signals. All those things are symbolic. So in Wolfram Mathematica, like today, you say maybe from statistical point of view, you might not find actually relevant, but sometimes that you will find in the cases, in the situations that the things actually could be very straightforward when trying to understand certain things. When you see a picture, you understand 1,000 things. Now, okay, let's go something slightly more serious. Now, inside here, if I talk about the data just now we have, if I do a list block, the list block means that I put the X, Y axis differently. X axis is the inter-duration of bursting time. Y axis is total duration when the fountain bursted. Yeah, so in this case, where X, Y, that means that you see, hey, there's 2 groups here. Now, I'm doing here, now we are doing something called, I wanted to put 3D. Let's say you have multivariate kind of plotting. How do we handle this? So now if I say I want to put it in probabilistic distributions, now it's more multivariate. So you can view from X direction or Y direction, which I can view it from in terms of probabilistic distribution functions for the inter-duration of bursting time, or the total duration of bursting times, the probabilistic. So in this case, I can easily turn to a 3D histogram like this. Yeah, very easily. I just say I want to make it to be a bin with 20 data inside here. For instance, if I want to make it even thinner, that means that actually I make it to be more data to be more scattered like this. So I can adjust accordingly. This probability distribution functions. Now I make it to 10 strips, yeah, from X, Y directions. So it's turned into histogram 3D. I can understand, actually visualize much better. So now, let's say we turn from it again. I want to do it slightly more programmatically again. Something like table. Table means just now I show all the moments of descriptive statistics just now. But now I don't want a table out. To show graphic in Wolfram Mathematica, we call something called graphic grid, meaning that it create a grid table accordingly. A grid table means that I want to show all the 4 things like this. Yeah, 2 things on the top. I want to list block my data. I want to do a density histogram based on probabilistic distribution function. You see here, probabilistic density functions. Yeah, and down there, I want 2 more. The first one is histogram 3D, which I just shown just now, histogram 3D. And I want to have a smooth histogram 3D. And this one is after it gets smoothened. And so in this case here, I can actually try to display things in a grid format according to the way I want it. So I just arrange it like code verbally like this, 2 on top, 2 on bottoms, and it show up in grid form very nicely. And of course, some of you might have in your mind, hey, if this is the case, can I actually deploy a website, can put mobile device? Of course, this is not today's topic, but in case you're asking this or thinking your heart, yes, today, all the so-called advanced software, they have to easily deploy in a manner that people find it easily to access. You can easily just one code line, deploy in the mobile device, Android, iOS, doesn't matter. You can deploy in Linux, Macintosh, Windows, and put in a website or in almost 1 or 2 lines code. Now, in this example here, I will not go into details about the until the end analysis, because this actually is one of sample file we do for machine learning. But I only talk a few parts because it's relevant. I want to explain concept correlation. Now, correlations is very important for data analysis. It's not something difficult, especially you usually learn even in Form 5 already. But now, but the good thing is when you have a lot of data to deal with, this thing becomes very important. If you could see, I'm trying to import the Excel file, something called blood donation campaign history. Yeah, I import 2 times. First time I say from worksheet number 1, but this one I say from row 2, is row, column. Row, column. I say I want to have column 1 to 5, column 1 to 5, but this one is row 2 onward. This is row number 1. What does it mean? Now, if I open up this Excel spreadsheet, this Excel spreadsheet is a very common things that you probably have been dealing with in day-to-day basis. They have actually four things to deal with. And today in machine learning kind of data analytic environments, and even if you do have machine learning, you deal with this a lot. Yeah, you say, hey, I have a lot of attributes, and all those attributes contribute something. For instance, I look at all the prospect, and behind is 1010 is to show that this person actually, after having this all attribute, he actually donated blood. So then we come to the conclusion, certain people had certain attribute have higher tendency on donating blood. So now, that's why we need to come up with certain correlation. So now I just do an import. You see the whole import, very simple. Let me see. Now, let me try to put something. Let me make sure the file actually is in the right place. Just give me 1 minute. Okay. Okay, now the file is right place, sorry. Now the files now is a folder. Now it's imported successfully. Now the next thing I say, I want to look at correlation. The correlation is very simple. I just put this correlation, but in front here, actually, this thing is no need. I say it is in table forms. This correlation looks something like that. Yeah. Now I say, hey, I want to look at easier for me to see. So I say I put in table form. So this is something that usually you see a textbook. So, but you see here, the correlation here it basically is if you put here nicely, is x1, x2, x3, s4, s5. On top here, x2, s1, x2, s3, s4, s5. So in between here, there's 1, 1, 1, 1. Actually, you know the C. The only correlation you need to have is x4, for example, x5 versus x1, s5 versus x2. So the last, this is data I want to extract. So programmatically, actually, I can easily extract it out. I say, hey, I only want the last row. I say -1, last row. I want the column 1 to 4. So actually, then you extract out from, oh, this data, I extract it down here like that. Yeah. So this is some more like kind of kindergarten thing. Yeah, it's not something that you find very wonderful. But the reason I'm showing you is when I say that programmatically, meaning that actually this whole line actually can put all these 3 code I can put together, immediately I achieve the result. So right away I say, hey, I'm looking at this whole thing as if now this thing is like -0.03. The meanings this attribute actually does not really affect the person who will donate blood or not. So maybe I only have to take care of these 3 data. So this is a very simple example. But let's say we take something more slightly complicated. Now in the manufacturing environment, this is a manufacturing environment. I import same thing a file, but this time this file is slightly larger. This is something closer to reality. In reality is today, if you want to determine, right, in anything in a system, actually is quite complex. Yeah, a thing works or do not work. A thing considered faulty or consider actually pass the quality. It could depend on a lot of things. You see, I put on top here purposely, 1, 2, 3, 4, 5, 6. Altogether, these are 36 different parameters to decide whether this equipment is working or not. So in this case, I want, if I had a easy today, we talk about big data. Yeah, you're talking about 10 of millions of data per day. Yeah, big data. But today, sometime in the environment, we could be dealing few thousand data per day. And talking about 10 days, also talking about 10,000. So if you want to do a correlation like this will be major impossible using Excel spreadsheet already. I used to have a project with CyberJara with one multinational company. They're doing the telephone call, telemarketing call. So the data actually, if you Excel spreadsheet, almost crash my Excel spreadsheet. Excel spreadsheet has limitation due to memory. But now in this case, the correlation here, merely 36 row of data, it come out correlation right away. So if I programmatically using the same approach, I say, hey, I only want to extract the bottom 36 row, which I can see it. Same thing, the bar chart here. You see the bar chart immediately come out like that. So, but of course, in this case here, I say, hey, I want to see something easy for me to understand. So I say, I just add in a few more things. Now, down here, this whole bar chart, I only add something called the origin to left-hand side. I want to put it to the left-hand side. I want to put a chart label. The chart label, I want to follow the Excel spreadsheet label. I want to plot a label, something called fault correlation. So the whole thing will be very easy to understand. See now, I put it like that, actually vertically, and altogether 36 correlation chart come out. So immediately I know which one is correlating, which one is not. Immediately I can choose certain data to omit from my system. I don't have to spend so much to maintain. Your IT manager will love you very much. So in this case, I say, hey, now if I want to block it actually numerically to someone to see, to import it, yes, you can actually they do it like this. But what if today I say, hey, anything in this on top here, anything here like this one, some of those things like minus, if I move this slide too small, and make it slightly bigger, but this is very small correlations. So I say, in this case, if I do a little bit more programming here, just one line of code, this is something like if then else. You have seen in Wolfram Mathematica, we have something called if, we have something called cases. The same thing in Excel macro, you use if a lot, IFF. So in here, I'm using something called cases. You say cases, this one is less than 0.1 or bigger than 0.1. These are correlation I want. The rest I don't want. So it come out actually only less than about 12 parameters, which are lesser than 0.1 or bigger than 0.1. So these are the data I want. The rest of the data I do not want. So I know what I can maintain. So using this programmically approach, only a few lines, it's not easy to code inside Wolfram Mathematica, but actually it's very powerful to deploy. Now, of course, talking about descriptive statistics, we can't wait a little bit for money. So when talking about money is to everyone concerned. So then people will say, hey, how actually, Wolfram Mathematica then used a lot in banking industries. People doing derivative analysis, oil and gas, stock market trading, they use it a lot. For instance, inside, like I say, Wolfram actually have a lot, something called curated data or repository. It's public, it's free. Curated means it's being organized for you in a format that you can consume right away. You also can upload all repository to share with the world. So this financial data is something that Wolfram get it the third party free of charge for you. So I put it here, I say, how many does Wolfram know? You know 57 currency. It know about exchanges on certain market, 13 of them. And he even know that stocks, 35,000 over stocks number in the world. It might not know every single country, but you say 35,000, there's a lot of company you know about. Let's say we get something most popular. I say I want to get financial data, like this one is stock index from Google, from 2018, 2020. To keep the time short, I don't want to get past 20 years. Of course, if you want to get 20 years also can, but the whole thing is download from internet, might take about 30 seconds. So now I just take the past 2 years, 640 points, about 1.5 years from now. So this 1.5 year stock performance of Google. So now, if I have this thing here, the next year, of course, I can start doing certain normal statistics, simple one. I'll not go with something like the broker will do. Now I do a moving average of 30 days. And this data here called stock Google, I already when I download it from Wolfram repository, I say now please do a moving average of 30 days. Now, you give me a moving average 30 days. Of course, in this situation here, you would not give me data. The good thing is everything output in Wolfram Mathematica is in symbolic way. Symbolic means that you look at this, oh, you say, hey, I know there are 611 data in a unit a day. It's there. But if I want to get data, I just set something called normal, and you change to data form. Yeah. So you're running all those things. Again, in a symbolic way, 600 old data point, you can actually copy and paste or export somewhere. If not, I do not put normal, it's a symbol. Yeah, it becomes symbol. It hold inside this particular symbol library. Well, and the next thing is, if I have this moving average available, there's some other useful things that, for instance, I say, hey, I want to find a peak. For me, analysis, sometimes I want to look at market adjustment. I want to look at peaks. Yeah. So the tendency actually making a change or adjustment. Like for instance, the Malaysia stock currently crazy. I'm not blaming stock, but if you pay attention to news, you know the stock market recently are dangerously crazy. Suddenly after post-COVID-19, a lot of stock market just grow like crazy. So people are expecting there could be adjustment. So in this case, let's say I want to look for potential adjustment. In Wolfram Mathematica, it's very simple. This is Google stock for past 1.5 years. I use a command called show. Show means that I can have lost visualization, put the same chart together. It can support in poses very nicely. First thing I say, please give me the daily plot of Google stock. Secondly, I say, please give me a daily plot based on moving average, which is this one in a little bit light green color. And also next thing, please give me, find me the peak, yeah, the peak of a stock Google. See, whenever you're making adjustment, yeah, you give me some 13 labels showing that adjustment is green color. So now I say, hey, if I can do this, can I do this programmatically? Yeah? Wolfram Mathematica is very powerful doing programming, as I mentioned it, and also you can create your application on the go. Now, if I put in something called daily plot, I say daily plot. I want daily plot, something called moving average. Yeah, moving average of what? Financial data. But previously, this one is called Google. Yeah, I don't want Google per se. It's 2018 and 2020. I make it to be a user variable called stock. User variable down there, I say this user variable, I want it to be Google, Microsoft, Apple. These three things become some sort of array of variable. So in front, I put a manipulate. So system actually, when I run this thing, immediately becomes something new. It becomes something like this. You see, this become a wonderful user interface right away. If I can show the moving average of how many? 10 days of Apple, Microsoft, and Google. So if I can do this right away, so then common sense tell me, then I can probably add in more some of the variables. Let's say I don't want a moving average of 10. What if I want to have a moving average of something I can choose from? So down here in this particular coding, I say, hey, just create one more user variables. Moving average like 5, 10, 20, 30, and 40. And this moving average variable, I want to replace this thing. Can it work? Instead of 10, I want to be user variables like this. I run again. Now, immediately in this whole interface come out a new one, a fresh. So if I make this thing bigger, so on top here, say this one is Google. Yeah, we are moving average of 5 days, 10 days, 20 days, 30 days, 40 days. If I switch to Microsoft, a moving average of 40 days, this is how it looks like. So of course, it is up to your imagination. You can put in more and more. And of course, lastly, some of you say, hey, can I do forecast? Yes, of course, forecast have a lot of approach. You can use machine learning. Some traditional one are using, like during 20 years ago, I learned in college, you need to understand about how to use something called ARIMA process. Yeah, so I will not explain a little bit too much about ARIMA process. This is one algorithm for actually forecast. So of course, to come out with ARIMA process, the whole thing is quite complex, but how to come out with parameters. So for instance, you say, hey, Peter, how do you know this parameters 2, 1, 1? Yeah, this is something I did some research I put in here. Say, I thought this ARIMA methodology is the best to describe Google stock. So I put inside here, I just superimpose both of the display just now, date this plot. So the last part here is this forecast using ARIMA approach. Of course, if you want to look up the what's whole methodologies and whole available parameters for ARIMA. You just go hit help file inside Wolfram Language. It gives you a lot of explanation. Now, the next thing is I need to quickly move on. Like, if you're dealing with data analytics, today, of course, we're not a topic of data mining, but but you can run away talking about clustering. And clustering today, talking about unsupervised machine learning is very important, but today we not go into this area, but I still need to talk roughly about cluster. Yeah, like this thing, this data set too, of course, you can import like 10 or 1,000 data point from anywhere, like external source, even Google Drive. Yes, we putting out a lot of data, this is on cloud, you can easily connect to your personal Google Cloud, or Dropbox, no issue at all. So the reason I put it here is for you to easy to understand, also for you easy to play with, because like I promise, usually end of session, we will distribute this file to all those participants today, so you can go back and play with that. So I put data here for you to easy to understand, play with. So the only one simple function here is called find cluster. Yeah, find cluster what? Find my data number 2, which is on top. I say, okay, now find for me. The system immediately looking up cluster to break down. So if you can quickly take a look, it seems like, hey, there's curly bracket here, there's curly bracket here. SAP already broken into 3 different clusters. Now, if you want to visualize it or do a bit programming, now, again, this programming is not a bit commastic. It is nothing actually different from top. The important part is find cluster. I already found the cluster I want. I put the cluster down here. I say, please do a list plot for me. I want to do a list plot of 2 things, the original data and the data which I already found the cluster, and the rest is I put a frame around, frame style. I want to take image size, I want to be large. I don't even have to put some of the commastic. I make it to be something simpler. Yeah. So now here, immediately do a comparison of these 2. Original data on left hand side and the cluster data on right hand side. It seems like it broken down 3 different colors. So we know the system actually now have found 3 clusters. Of course, there are many other methodology being behind how to, you say, hey, I don't want to be this 5 cluster. I do not know even what methodology you use. I heard about k-means, things like that. Does it use k-means? Yes, those actually some of the parameters are going to, you can specify if you want to. If I do not specify it, system will take the default or take something most efficient one to give us a result. So the next thing quickly, this thing I will not, you can actually take a look on your own. This little round shape thing, if I make it bigger, I click on that, it can expand bigger. You show me the comparison between SAS, R, and some of the popular statistic package out there. The red color is Wolfram Language. Wolfram Language actually have a lot of distributions built inside compared to other packages. A lot of other things you will not even use in a lifetime, but it is just why this to let us know that you have a peace of mind. All those things actually, whatever you somehow it cross your mind, is there available. Now, we haven't talked about big probabilistic density function and cumulative distribution function. How do we generate random variable? So now, it's a quick example here. Now, in this case, for instance, I want to generate normal distribution with the mean of 0, with standard deviation of 1. I want to show you probabilistic density functions. So immediately give me a formula like this. Yeah, the formula here is standard in the textbook, but I say, hey, if I want to show it to me to myself, how does it look like? I can easily here, you see the whole thing, the syntax still the same, probabilistic density function. Now I say I want to give it X will be form 5 to 5. Yeah, please plot it for me. I want to make myself to have a look at that. If I have a normal distribution in x-axis, -5 to the left, -5 to the right, how does it look like? Yeah, immediately plot for me like this. Now, here's a very simple thing. What if today you want to generate some simulation? Inside Wolfram Language, generate simulation is very simple. It's called random variate. Behind that, just put any distributions like 50 over distribution available inside Wolfram Language. And you just say, hey, generate for me a 10, please. You generate for me a normal distribution of 10 output, yeah, like this. So you can do a Monte Carlo analysis very easily, like this is use random variate. If using the example now, this is really classical thing. For instance, people use a lot Poisson distribution to find out what will be average defect rate in a batch of good? Or what will be the average people who show up inside ATM machine? And because, like, for instance, people use this thing for queuing theory a lot. So today, of course, I'm not talking about queuing theory. I just want to show to you how we can generate random variable very easily. Again, same thing. Instead of normal distribution, I say a Poisson distribution with lambda of 3. Means averagely, every minute, I have 3 persons show up. I want a random variate. Okay, generate how many of them? I want to generate 60 minutes. Yeah, 10 times time. Oh, too many, never mind. 10 minutes times 60 seconds. Every second, 3 persons show up. So now, in this case, it will show to me, altogether, it show me 600 data points of based on Poisson distribution with lambda of 10. Now, if I hide this thing, I say, now show it to me these 600 points, that's how this look like. Easily show it to me how, if I generate 600 points based on lambda of 3, which is mean of Poisson distribution, this is how it looks like this. Yeah, maybe in reality, every second is how is possibly how many number of people show up in front of ATM machine. Yeah, assuming it's a very busy ATM machine. In this case here, quickly, and this is a very powerful thing. We can do a probabilistic again to answer some of the question already. If I have Poisson distribution of 3.0, or I'll put it with 3. If I put it with 3, I say now, what if I have X here? I have X. If I want to know any one time, let's say next seconds, what's the chance of having 4 persons showing up in front of this ATM machine? Based on Poisson distribution with a lambda of 3. Immediately show me this thing is symbolic output. They say, hey, this symbolic output is exponential cube. How does it look like? If I put 0 behind, system already know I want to perform something numeric. You say, oh, it's about 35% chance now. The next second, you have 4 persons who show up. Yeah. So this is how easy it is. With a function called probability, behind has distribution, the in front here ask questions. Yeah. So with these distributions, if I have certain value of X, what will be the probability I'm talking about? In this case, we can do a lot of projects already. Now, for instance, in this case here, in further look at multivariate distributions. In this probabilistic distribution here, now for instance, I have cumulative distribution functions, multivariate, yeah, Poisson distribution. Now it's in 3D. As some people say, hey, can I look at 3D? Yeah, yes, you can 3D. I just quickly show this how multivariate is being done. So I'll go into a quick application. How do we actually using probability to answer certain questions? Now, in this case here, same thing. I'm using a table. I say I want to plot discrete plot 3D cumulative distribution function. Cumulative distribution function with multivariate Poisson distribution, which having a mu 2 or 3 and X will be from 0 to 15. I want to plot it 1, 2, 3, 4, 5, 8. Mu could be 1, 3, 4, 1, 3, 5, 8. So immediately show me 4 possibilities down here. You can play with it when you're free. Now, the next thing here, what if you are deriving your own distribution? Yeah, this is very interesting. If you have somehow, don't know, maybe in your research, somehow you come up with a distribution like that. You say, hey, this is my distribution. This distribution in the system cannot be found, but this is my distribution. You can actually use this function called probability distribution, assign with a name called probat this. I change it, I don't like this name. I call my distribution. This is my one. Yeah. I say this one is probabilistic distributions. Now, when this is created, same thing you can use approach. If this thing create already, I can say, ask the system to show to me what will be if I have a probabilistic distribution function already. I want to show the cumulative distribution functions based on this my distribution is created. Does the system give me a formula like this? Yeah, convert to CDF. Yeah, if I want to visualize how this will look like, that's very simple. Same thing again using plot function. In front there, this is your my distribution in PDF, which is your probabilistic density function and cumulative distribution functions. Yeah, I put like that. And I want to be X from 0 to 11, immediately can visualize right away, both on the screen. Again, same thing like what you have learned just now. This whole thing, if you already know your X actually is your own distribution that come out with, you say at any one time, I want X more than 4, yeah, more than equal to 4. Can you give me what would be a likelihood is? You see, this likelihood. Oh, this is so like 10. Oh, this thing, then if I want to convert it to some numeric computation and put dot 0 behind, it give me a numeric output. This is numeric estimation. 27% of the time, you likely more than 4. Yeah, so it's just that easy. So if you want to do now, another interesting example here. I mean, we know men and women different in height in the average. What if today I want to have a distribution function to describe human being, in regardless of man or woman, about their height? So in this case here, if I have somehow the example here, say a woman usually about 64 inches high. Now about standard deviation is 2 inches. Men usually 70 inches, a bit taller, because this data I told you to some Western world, so it's taller than Asian. I do not get the standard deviation of women in ASEAN yet. They have average value, but again, you see a lot of statistics out there, right? You look at some financial, the officials data side, sometimes they are lagging something. They're telling you something, but if you want to do further analysis, really on your own. Now, the population ratio of males to females is 1.1, meaning that for every man, 1 man, there's 1.1 woman. So again here, if the equation used here is called mixed distribution. How do we mix two distribution together to create new distribution? So the distribution of man here is 70 inch in height with a standard deviation of 2 inches. Same thing, woman here 64 and standard deviations of 2, both are a normal distribution. But in front here is a weightage. Weightage means that I want to correct it. Now in this sample, in this sampling, so I have 1 man to every 1.1 woman. So in that case, I actually have to do a reverse. And in this case, I need to assign higher weightage to man, which is 0.5238, and woman is a reverse lah, minus 0.5238. So now I want to plot a probabilistic distribution function using this function called mixtures distributions. So see how the system handle it. Immediately system handle it very well. So these 2 normal distributions actually put together. Same thing, if these 2 normal distributions put together, you can start asking probability, things like that, so on and so forth. Now, again, if some of you actually seen Wolfram mathematics first time, even though in my opinion, it's very, very easy. A lot of people say very easy. They say, hey, Peter, now I'm from the area of chemistry, and then we do that much of coding. Scare me, how to do that. Now, not to worry, if some of you attended our previous session, you know we have something built in, which is almost AI kind of approach called free-form input. So in this case, I put a free-form input and say, could hit equal sign. I hit equal sign in the system. The system actually show like this. Meaning that actually now I'm using the AI inside the system here. I just type in plain English. I say average. For instance, I don't want to say average, I say mean. And maybe the system understand. Say mean 30, 32, 35. Oh, I understand actually. Say mean means actually average lah. Same thing here. If I run this thing, average, the system connect to internet, it say it's something you want to do. Then I say, can you give me a standard deviation? This is something as simple, I put in pen, paper and pen already. Yeah, I just type in plain English and say, I want to do a bar chart. Bar chart like this, can. Then it come out like that. So now I say, I type plain English, can you linear fit for me? Yeah, so if you have a lot of data, sometimes you lazy do coding and you lazy put an Excel spreadsheet, you just copy and paste, dump it here in front and say, please do a linear fit. The system actually do all the fit for me and do the least square fit for me, and it show a lot of explanation here and there. Yeah, then up to you to decide what you want to do with that. So again, Wolfram Alpha, we talked a lot about that in our separate sessions. So today we'll not speak here. But to close the case today, we left in about 5 minutes. So I show a couple of examples. Then you know what it means that today, if you have an easy package built from top, very simple to how you can actually deploy it, there's so much thing you can achieve. For instance, today you want to decide whether I should build an airport somewhere. Let's say inshallah, it's already there. You want to do a weather analysis. So if you want to get data, today you do data analytics, you have to deal with how to clean data, all those things. But today we're not talking about how handle your data, how to clean or transform. Today, you want to assume all the source data actually is cleaned up already. So now, Wolfram have a lot of repository. For instance, this weather data, you talk to our weather authority in Malaysia, you're not going to get it. But somehow, Wolfram actually managed to have connections, data access to the world data, which actually collecting for all the weather stations in the world, including Malaysia. We have about 10 over weather stations collecting data in hourly basis. So Wolfram able to access data even up to our Merdeka Day, 1957. Yeah, believe it or not. But today I want to make it faster. I just get 10 past 10 years Subang Jaya. Yeah, these are wind speed. Yeah, the wind speed, the kilometers per hour or the past 10 years. But with this data coming out, you can visualize, immediately can say, I want to put into 200 strip of probabilistic density functions. And after that, if I can put it this histogram, I want to use a function called smooth kernel distributions. I say, hey, I want to smooth kernel it. And then after smooth kernel, please describe for me the probabilistic distribution function. So system actually based on the fitting, the algorithm we use called smooth kernel to come up with a mathematical function like that for us, like this. This is functions. To us might not be readable because inside there has some symbolic object inside there, because this is fitted by computers. Yeah, it's not actually 100% mathematically, but actually it's a lot of interpolation built inside. But now I want to see, let's say, visually how does it fit. Assuming I'm not doing the hypothesis test, I'm not doing ANOVA yet, but I say I want doing basic visually to see how does it fit. It looks like it fits okay. Now let's say I take it as is. Yeah, this distribution function I come out with, I call A. I want check any one time in this Subang Jaya, the wind speed more than 5 kilometers per hour. It says 64% of the time. It looks like this area is quite windy. So now the next thing is, if I want to get further more data, I say, hey, what if I want to get wind direction? To build an airport, you also need to know where the wind direction is blowing. So you want to know which runway you should lay. So in this case, I say, give me a past 5 years, because this data actually is quite huge. I think because compared to the wind speed, they might actually collection one a day. This is a wind direction, they're collecting data a few times a day. So even 5 years data is huge. So it's running in the system a while, but let it run. Yeah, so it's collecting from internet. The next thing is, let's further move down. What could we do with that? Now, there involves some programming down here. But let's put aside this programming. If you already actually going through some short videos, you know, I'm doing a lot of domestic thing down here. A lot of things actually is not important. But now here you see, in the past 4 years, the system say it collected all together 47 point of data, 47,000 point, 47,397 data point of wind direction in Subang Jaya. So in this case, it say I want to visualize it. The system will show something a very congested display of 47,000 data point. You want to do Excel spreadsheet, likely you crash it. But in this case here, where it still do a calculation, it looks something like this. It's crazy. Yeah, I cannot even tell actually where the wind's blowing. It's like based on 0 to 360 degrees. You know where it's blowing, but you know it seems that there's a pattern available. A certain day or the week, they are blowing certain direction higher. But let's say I don't want this thing. I don't care about this thing. It's still running on top. Let me see. 37,000 points take a while. Okay, let's see whether I can come on down here. I have to let it run. It take a while to run. Okay, now while it's running, I'll come back to that later and see what's the result you will have, because we're running out of time. Now, if you want to do linear model fitting, let me explain it just a little bit. Linear model fitting, of course, you can do Excel spreadsheet very easily also. I import this thing from Excel file, yeah. Say, but in this case, I want to fit the calling x and x squared and x cubed in terms of x. The formula was simple called linear model fit. And the next thing is, I say, I want to do after I do a fitting, the system actually show me this is how it best fit for us. You can do Excel spreadsheet easily, but later on I show to you how to do nonlinear model fit, which will be very difficult. It's impossible in most of software. But I will not say Wolfram Mathematica will come out nonlinear model fit all the time, but sometimes you can come out quite well automatically. I'll show you how. This is linear model fit. Yeah. After that, of course, you say after doing model fit, I want to do some ANOVA analysis. And seems like in terms of F value and P value, F value very large compared to P value, means it's fitting very well. So of course you say, hey, inside that, what else can I perform based on this data? Aside ANOVA table, it also can do beta difference, correlation metrics, things like that. There's a lot of things actually can use this data. Okay, let me go back to the previous one, see if actually done with the display or not. Yes, already done. Go. Good. Okay, it's done. Now, if this done, I want to do a visualization quickly to show that actually how the wind direction is blowing is Subang Jaya. Okay, down here, it takes a while. It's about 3,000 over data points. So the whole thing will come in the plot. Actually, take a while. So in this case, immediately I know if I look at north, south, west, east, and it seems like about, you see, I mouse over this thing, right? It showed me the probability. This is about 6% of time. This is about 5% of time. This is another 5% of time. The wind is blowing from the northwest direction. So in this case, you could come up with last 5 years about 37,000 data points to justify that your statistical analysis is something that actually is valid. So now the next thing is, for instance, to make sure a model is valid or not. Of course, you cannot run away with hypothesis testing and ANOVA. So today, let's say I'm taking this example. I'll assume male cat and female cat, right? In terms, we want to compare their heart, their jantung. Okay, their jantung. Say, I assume that female cat and male cat, right? Their heart actually are different size. So I'm taking from my example here available called Fisher cats. This example. Inside the example statistic available from website, they have the gender, heart, okay, which is the heart weight, and the body weight, the heart weight and body, the heart size, the size of heart, the heart, the size of the jantung, okay, and the weight. Now, if I have this thing data available already, next thing I can do a quick location test. There are many tests you can do by using location tests. I say I want to compare the heart of the sex is based on male, and also the heart with the sex is based on female. So the test table show it to me, okay, the S value is very high, P value very little. It seems to tell that, okay, this hypothesis is true. The male and female cat, the heart size is different. But let's say, we say maybe actually it's due to the bigger size of cat is the bigger size of heart. Could be small cat, small size of heart. So it means that actually maybe male cat actually usually the body size bigger. That means it can contribute the heart size also bigger. So I take a ratio, heart divided by weight based on sex, male, heart divided by weight, sex is female. I want to do a smooth histogram. Again, I want to do another, this one superimpose there. It seems that, hey, actually there is no much different. No? This, if I put in the ratio between heart and the body weight, right, it seems to be actually either male or female are same. No? But is this true? So these two things, again, I take the variable I generate up there, male HBR, female HBR. I put into a test data table using location test. Again, now the S value and P value very different already. See, S value and P value on top, compare this one. S value actually become very small, P value increase, means actually it's no difference. We can actually deny this hypothesis, say that it's not true. Now, the last example here, this interesting one. Also, if I want to measure using this data, as again, you cannot get anywhere from Malaysia's authority. Sometimes, I do not know why. But this data somehow available directly from Wolfram. Yeah, trust me, I've been searching up and down Google for a few days, and we really can't find it. Now, if I check with type table, raw data maybe yes, some Excel spreadsheet authority published, but you want to get something like repository like that's not possible. I want to get data past 10 years from the kampung where I live, Kelang. yeah, immediately give me a 522 data points, yeah, based on weekly basis. I say, give me the sea level or tide level in my area, clan where I live. Because my area live, I usually last time have problem with flood. So I want to see whether in this, I want to see there's any patterns of sea level be changing. So now, next thing, again, you see, I'm using this function over and over again. And again, this block style, block size, medium, all those things are domestic. Only things that matter the most is the data. And true, no matter where the data coming in is internal data, external data, as long as the data actually organized in a way, understands it, as most of the time actually is almost plug and play. So this is a tight level in Klang in the past 5 years. About 500 over data points all available in weekly basis. So if you want to visualize this data, I say, can you find formula for me? This is where interesting part come in. Now, this thing you definitely cannot do it in most of software. Definitely cannot. Don't tell me even Excel. Now, in this case here, the system come out with non-linear fit. Surprised me actually a few years ago. I found it. Actually, how come we could do it? Because non-linear fit usually you need to know the pattern in the first place, or you come out. I do not claim it. This formula is correct. Yeah, but I find in few occasions the fitting is correct. Yeah, in this occasion I have not do a hypothesis test yet, but it seems to be correct. Yeah, this is actually a formula that describes the type level in Klang. Yeah, there's something there is actually missing data for some reason. I think our authority did not submit data to the Thai station, because I think there's a world organization monitoring this thing. You see that some of the weather data in Malaysia also certain few days also missing certain gaps sometimes. So you come out something like that, but it's good enough. But in this case, if I say this is model it come out with just now, I want to put it in the original data, see how it fit. You see, I put it original data. This is like 500 over data, 300 over data points in the past 5 years, compared to a non-linear fit. It just come out. It looks actually fall into place correctly. Looks like, yeah. Now, same thing. There are some other things today. I'll not go into hypothesis test or NOVA. I'll just let you know if you can continue on if you want to. That you can do that. But other interesting thing is there's so much things actually when you program it. For instance, in this case, I say Klang, Johor Bahru, Perai, Kota Baru, Kuala Terengganu. These 5 different cities at high tide level. Can you give it to me? Yeah, in the forecast. Yeah, the system even have forecast. It can come out a lot of graphical explanation. This is something actually fantastic, very fantastic. See, surprisingly, you cannot find it. Definitely can't find it on any authority website. I so much hope that actually they will use it. Some of this software, for instance, in this case here, say Johor Bahru, and now Wednesday, 22nd July, and 1 o'clock afternoon, this will be tide level. Compare apply, be higher one, Klang be low tide, Johor Bahru be higher tide on this time. See, actually, it show actually a chart very clearly to show this found. I think today somehow some data are not available. Let me see, let me run it one more time. Yeah, some of the data are missing. Okay, let me see whether it'll come up later. So I think I'll conclude most of the thing today. Of course, there are some other applied statistic you can work on. So if you have any questions about, hey, in my domain, some particular domain, my statistics, I'm more concerned how to apply some techniques. I might not have covered here, but do feel free to email to us.